Please welcome the director of the Five Gyres Institute, Mr. Marcus Eriksen.
Good morning. Thank you, Keep Norway Tidy, for inviting me to the conference. I've had a long desire to come to Oslo, to come see the raft that inspired my expedition, that really got me started on this issue of plastic pollution so many years ago. So next slide, please. So about 10 years ago, I rafted the Mississippi River on a plastic bottle boat. I grew up in New Orleans, just south of Louisiana, and when I finished that expedition, I sort of thought, where does the trash go from here? Leaving our coastal watersheds around the world, debris is floating into the subtropical gyres. And I wanted to find out on my own what that route was, to follow the path of garbage. So I built a boat out of garbage, and I called it Junk, the Junk Raft. You can see here there are 15,000 plastic bottles under an airplane. I think it's the first airplane to float across the ocean from Los Angeles to Hawaii. But this trip I had planned on a 6-week voyage. I figured in 6 weeks I would be done, and I'd be home. 4 weeks, I thought, at the most 6 weeks. So 13 weeks later, we're drifting into Waikiki. When I was halfway across is when I ran out of food. Out of food completely, down to actually peanut butter. So I had good protein and fats available. And I was fishing. So next slide. And I caught this fish. There's a video that goes along with this. It's called Plastic Sushi.
So I filleted this fish, thinking I'm going to eat it, and here's what I found. It's full of plastic. This is the whole reason that we're out here, to bring this to your attention. The plastic isn't benign. The fish won't pass it. The plastic is full of persistent organic pollutants, things like PCBs, DDT, PAHs, things that are known human carcinogens and endocrine disruptors, things you don't want in your body, but they're in the fish that we eat.
I don't want plastic for my sushi.
So that was one of about 30 videos we made at sea, which I could send on my little MacBook, very low resolution, to my wife on land, who then had our blog going about the expedition. And it was very effective in terms of public awareness. We had about 1 million people looking at our website the day that we arrived. But this also sparked a lifelong interest in microplastic waste, the impact it might have on the world, and just how much of this trash is out there. So we set ourselves to discover what the standing stock of plastic is globally in all 5 subtropical gyres. Next slide. So if we look at how we got into this mess, if we go back and look at the early magazines post-World War II, when this issue kind of began, you can see where the consumption of plastic waste. In World War II, we had the production of materials for the war effort. All that production shifted to domestic consumption, and you saw articles like this, 1955, called Throwaway Living. Actually, in the first sentence of this article, the author states that it relieves the housewife of the burden of ever washing a dish again. Just throw it away. And I like going through these old magazines. You see the advertisements of how plastic, this new invention, was being utilized in the world. Next slide. Oh, there's that quote. Next slide. And the next. There we go. So, some strange ways of using plastic waste. You think that is weird? Next slide. Very strange, and it gets worse. Next one. I like the kid here on the left. Next slide, please. So we look at the global production of plastic today. I mean, this is back in the 1950s when those ads were produced. But I'm sure that those that DuPont and the other companies had no idea this explosion of plastic that would plasticize our entire planet, both in what we're using every day, but also what's happening in the world's oceans. The distribution of plastics now is global. And you can see now, just in the last year, Plastics Europe reported 288 million tons of production globally. Next slide. And that's Throwaway Living today, where you can see in waterways around the world, and just last year I was in Bali and in Delhi, and in Indonesia and in India, and you see the same kind of scene. This is not an isolated incident. Now this is fixable. But that's the current state of throwaway living today. Next. So what's some of the mechanisms of loss? Next. So poor waste management. What we see in many developing nations is a lack of infrastructure for dealing with waste. Although they want the consumption of plastics, they want the convenience that we've enjoyed, but they have no way to deal with the waste. So we're seeing waterways like this being choked with plastic waste. Other sources of plastics in the oceans are the fishing industry, lost fishing nets. So ways to track nets, and that's happening here in Europe. You're seeing fishermen having to report the nets that they lose. But in the North Pacific, where we find the abundance of these nets, that system does not exist. And you see a lot of these microfibers appearing in our trawls, on beaches, and lots of large nets floating about. In fact, this net, next slide, can you back one? Okay, it's not there. Next one. Other sources would be cosmetics, other sources of microplastics. There are some designed microplastics, like in facial scrubbers, but also washing. When you wash your clothes, polyester clothing and PET clothing will shed microfibers as well, by the tens of thousands per wash sometimes. Next. And catastrophic events. And this cannot be overlooked because they're happening much more frequently, and they're producing a lot of marine litter that is fragmenting into microplastics. So lots of sources for microplastics in the world's environments. So we did an expedition from Tokyo to Hawaii and found large debris as well, including this half a fishing boat. So we estimate between 5 and 20 million tons of waste was washed out to sea from Tokyo during the tsunami 2 years ago. Next slide. So how does this stuff degrade? Once all this debris is out in the ocean, what's happening next? So there is some biodegradation that happens. There are some microbes that will eat small amounts of polyethylene. Very slow. It doesn't keep up with the constant flow of polyethylene and polypropylene into the ocean, but there is some biodegradation happening. Photodegradation and mechanical and chemical degradation. So you have these processes at sea that will take a plastic bag and crush it into, in a couple of years, maybe 10,000 particles. So at sea there are mechanisms that are producing microplastics from macroplastics. And fragmentation by grazing them. There are lots of fish that will nibble on plastics. In the North Atlantic, I've crossed here a few times, and you always find in the mats of sargassum, you'll find little bits of plastics that have bite marks all around them. It's very common. Up to 25% of the large items we find have evidence of grazing on them. Next. Again. So what are the ecological impacts? What's happening to this trash? Like, how is the marine ecosystem interacting with waste? Next. So this net, when we found this one, I took it apart. We hauled it up on the deck, and I took a knife, a dive knife, and just shaved off every recognizable, distinct piece of net or line. What I found in this 300-kilogram giant net ball, there were 89 different kinds of line and net. So the ocean kind of sews all this trash together. At the same time, it's fragmenting. We shook this thing like a piñata on top of our deck, and all these starfish poured out. At the same time, my hands were full of microplastic fibers from these nets. So they're aggregating, and they're decomposing at the same time. There's lots of life living on them. We counted 36 different megafauna on this net. And the microbes and the microfauna, I'm sure, they were much more diverse. So they become these little floating ecosystems of life on trash. Next. And you'll hear about halobates soon. I won't talk about this at all. But you were seeing lots of organisms taking advantage of the substrate of plastics to increase their populations. So it's not just one turtle, one whale, one bird. The impacts are tremendous. We're looking at evidence of impacts of marine litter, marine pollution on life is roughly 663 different organisms have been found to interact with trash in harmful ways. And not just in the ocean. We just acquired this for our traveling exhibit we have that's going around. It's a 30 kilogram mass of tangled plastic bags and rope that was found inside of a camel in Dubai. So you see here on land you're having organisms grazing on plastics also. But the impact in our oceans, we're seeing it happen to a lot of organisms and a lot of fish, including fish that we might harvest to feed the world. And it begins here. It begins at at some of the invertebrates, barnacles and zooplankton, lugworms and sediment. We're finding microplastics are interacting almost with the entire ecosystem as they precipitate to the seafloor. And not just passing through their bodies, the plastic is not a benign material. One little microplastic particle, if it's small enough, there's evidence that might transfer through the gut lining. So we have actually found these microspheres, in this case polystyrene, inside the bloodstream of mussels. So it's not just going through the ocean, dispersing, fragmenting, it's cycling through the marine ecosystem and into the bodies of marine life, and then up the food chain. Next slide. Up to different trophic levels, from mussels to crabs, going from the bloodstream into through the gills into this organism as well. So it's up trophic levels. And where the science is now, we're looking at which point does it include us? When we begin to find microplastic fibers in our bodies as well. And that research is on the horizon. Next. And like I said, the plastic is not benign. It's also a vector for pollutants. And I had a chance to attend a conference 2 weeks ago in France called Micro 2014. And I got a chance to meet a lot of young doctoral students producing some amazing work on the impacts of microplastics. And a lot of work was on ingestion, translocation into the bodies, but also transferring toxins from the plastic. You see, plastic can absorb all kinds of different toxins as it's floating out in the ocean. All these persistent organic pollutants, industrial chemicals. You have oil drops from cars, pesticides, DDT, will stick to plastic in very high concentrations. And then when they're inside the bodies of organisms, because of the pH of the gut or the temperature of the gut, they can desorb into their tissues and organs. And that's what we're finding. Next. So like the fish that I caught, that rainbow runner, this is a species you might see in restaurants, in fish markets around the world. So we're finding that the food chain that we harvest is impacted by microplastics. So in turn, we are eating our trash. Next. And it's causing harmful effects. The one paper just recently came out looking at liver damage caused by the desorption of these POPs into the tissues of some fish. So what's the ultimate fate of all this trash? Where is it going? Well, the life cycle seems to be that plastics are leaving our coastlines and also leaving from the maritime industry, lost derelict fishing gear, fragmenting into microplastics. A lot of it may wash ashore where it can be collected. But the microplastics, it's impractical, nearly impossible to recover that from the sea surface. Now, I won't say impossible. I just said it. It's extremely difficult to extract microplastics. What the fate looks like is that once they fragment, they can wash up on shore where it's hard to extract. It's distributed through the water column, hard to extract. And it's circulating through marine food webs until it likely is going to become heavier than water and sink and become sediment, where it impacts a whole other ecosystem in the benthos. So we're seeing the impacts are global, it's vertical, and it's in all marine ecosystems. So my interest has been the global distribution. Ever since I did the junk raft expedition and my river trip before that, I was always curious, how much is out there? Where is it going? And that's been the last 4 years of my work has been focusing on these expeditions. Next. So what we have done, we have traveled across all 5 subtropical gyres. Next slide. Next. The South Pacific, South Atlantic, North Atlantic, North Pacific, and the Indian Ocean. So in these 5 subtropical gyres, you have these accumulation zones, what we call garbage patches, but also there are hotspots in the world as well. The Bay of Bengal, the Mediterranean Sea are hotspots where you have a very dense regional population, coastal population, that's contributing a lot of trash to those localized environments. Next. So what we do is we use this device, very simple. We use this manta trawl and other trawl devices I've built to survey the sea surface. It's very simple. You drag this net, you count the particles inside, you weigh them, you count them, and you get an idea of the abundance. The abundance by count and the density by weight. Next slide. Next. So many expeditions. In the North Pacific, these are expeditions. Next. And what we find is very typical. So This issue kind of began with this one fellow, Captain Charles Moore, found the Great Pacific Garbage Patch between California and Hawaii. And what he found was this abundance of microplastic particles. So this is one of our samples, very typical. You occasionally find something you can recognize. In this case, a toothbrush. There is a spray cap there, a couple of pen caps. Can you see the gorilla? There's one toy gorilla in this sample. But that's the first little toy I found in a surface toad. In the middle of nowhere, a gorilla showed up in my net. Next slide. That's a little video I would like to show. North Atlantic gyre.
Let's bring it in.
Lots of larval fish, sargassum, and little plastic particles. Yeah, look down here. Look at that.
We're in the middle of the North Atlantic gyre, also called the Sargasso Sea. It's called the Sargasso Sea because of sargassum. It's a kind of seaweed that filled our nets. But it's also full of small particles of plastic.
There we go.
What you got, Anna?
I see one.
It's a mouthpiece, I think, for a boxer. It's got some barnacles, some sargassum. This is 45 minutes of scooping through another windrow in the middle of the Sargasso Sea. I think we found the Atlantic garbage patch.
Is that longer?
10 degrees to port, Clive, about 100 meters. Dun-dun-dun.
You know how gross that is? And that's why I married her. We can pass those around. These are some samples of microplastics from Easter Island I'd like to show you. So you can pass around and take a close look at this debris. Next slide, please. Hi, Miriam. Next slide. There we go, North Atlantic, this expedition. Next slide. And we saw the same thing, this sort of soup of small fishes and microplastic particles. Next. And then I just got off the boat in the North Atlantic, and I got invited by this boat, the Stad Amsterdam, to sail from Perth, Australia to Mauritius. It was an awesome voyage, the first expedition to the Indian Ocean. And next slide, we found the same thing. This background of microplastic particles, and very rarely you recognize something you can discern as a cup or a toothbrush or what have you. South Atlantic was our good data set, 104 samples in 3 expeditions, and we found the exact same thing, this background of microplastic particles. South Pacific, the exact same thing. Approaching Easter Island, what you see in these little vials being passed around, these small microplastic particles. What we found was that the planet is abundant in microplastic waste, but it's very difficult, if not impossible, to identify it to its source. If you can't identify it, then how do you place responsibility? Because the debris this waste is being found in the middle of nowhere, international waters. And it's broken down, it's hard to recognize. You can't attribute this to a company or a country. It's the ultimate tragedy of the commons, these microplastic waste in the subtropical gyres, these garbage patches. It's hard to get a country or even the UN to take ownership of this problem by focusing on what's out in the middle of the ocean. Next. What we found then was after many years of doing this work, we combined our efforts with a few other researchers, and we're about to submit a manuscript looking at the global standing stock burden of plastic pollution in the world's oceans, based on 1,571 data points around the world, coastal and across the gyres, and we divide those into 4 subclasses. So I took all of our samples and the samples from colleagues, and we separate those into fragments in the very top corner, the size of grains of pepper and salt. Over here might be in this top corner bits of rice or lentils, that size. Over here might be from lentils to a plastic bottle, 200 millimeters. And over here, anything above, the macro litter. And we have some interesting findings. So next slide. So we look at the count. You would expect that the least amount of stuff is the really big items. So yes, macroplastics are the smallest. And then you find more of the plastic bottle size litter, and then more of the rice grain size particles of plastic pollution. But what was unexpected was that this next size range, we have less. So what we think is happening is that the smallest particles are not where we would expect to find them. They're not on the sea surface. So there are some mechanisms at sea, and I mentioned some, the biodegradation, the UV degradation, the sinking. Something is happening that are removing the smallest particles from the sea surface. Next. If you look at weight, you see the opposite trend, where there's less weight in the largest, in the largest size range, or the largest count, but the most of the weight is in the macro litter. Now, the macro litter, the largest item, are fishing buoys. Make up 56% of the items found in that macro litter range. Next slide. So then what is the standing stock? How much trash is out there? That's our estimate. Using the best model available, plugging in all of our data to calibrate the model, we estimate 0.464 million tons from 5.25 trillion particles. What's interesting is only about 35,000 tons of that is microplastic, 5 millimeters and smaller. The majority is the big stuff, and a lot of that is washing ashore. Next slide. So focus on solutions. I don't think we're going to solve this by going out in the ocean gyres and sitting there picking up plastic waste. That's not where the focus needs to be. I believe it has to be very close to the shore, in our lakes, in our inland seas and rivers. So we did this one expedition to the Great Lakes. We collected 21 samples in 3 of the Great Lakes, and we found microplastic. I was actually very surprised. Probably wouldn't find much at all. Very small particles. I found more particles of microplastic in the lake sample than most of my ocean samples worldwide. So what we did, we looked at these particles under a scanning electron microscope, and we found perfectly round spheres. Unlike the ocean microplastics, these were very perfect and colorful, little plastic, purple and green and gold little balls. So I went to a local pharmacy, and I found a product that said microbeads. Next slide. And I found the match. Actually, these are the 2 that we analyzed. We looked at those under a microscope, and they were the same size, color, texture, and composition. The alternatives, though, we saw on the same shelf in the market were those 2 made from environmentally benign materials. And you can tell on the back, the ingredients, it's very clear. They're not hiding anything. These are microbeads. They're made of polyethylene plastic inside these facial scrubbers. So we launched a little campaign. We said, okay, we have this paper's published. We have evidence that these microbeads, possibly from these facial scrubbers, are polluting our environment. So what we did, we took these samples, along with, there's a group here called the Plastic Soup Foundation. It's done amazing work on this issue of microbeads. And what we're finding is that companies are responding. Next slide. And we had some successes. We've had Johnson & Johnson, L'Oreal. Here, the Plastic Soup Foundation got Unilever, the first company approached to stop using microbeads. So what we find is the solutions to this problem are local. They're here. They're in your rivers, lakes, and the nearshore environment. Going in the middle of the ocean to document plastic there, it's important to do that and to monitor this long term. That's not where solutions are going to happen. Next. And if you like sailing, which I'm sure many of you do here in Norway, please join us. Our next expedition next summer is from Bermuda to Iceland through the subpolar gyre. I have a few research goals there, so I invite you to come along. There's a couple seats left. Thank you.